Now, uh, this is where you do your make menu config. So uh, there's a couple things you keep in mind. So it's going to give you the default config, right? But you need to go ahead and look through here carefully because there's some things in here you're going to want to know. So it depends on how exactly you're wanting to build a kernel and what you're wanting to build it for. If you're building it to be lean, mean, and fast, but you're not want to track the IOs, then you're going to want to, there's a few things you're going to want to keep in mind. You're going to want to go to the preemption. Now, if you do no preemption, you're going to have high throughput. The lower latency, the lower throughput, but no, the lower throughput comes with the lower latency, and then the higher latency, which would be no force preemption, would be server, would be higher throughput, which means like you're just able to number crunch better, but it doesn't respond as fast. So whenever you make it so it responds faster, you're giving up throughput. Anyway, from all the stuff, from all the real time's nice. It takes a huge load. Preemptible kernel is pretty much what I like the best, unless you have like some psycho supercomputer, then real time all the way. Real time is very nice though. It does have some benefits that some of the coding is a little more professional and stuff from what I understand. Anyway, CPU task time and accounting. This will take some of your hardware monitoring capabilities away, especially with IRQs and stuff like that. But it also it takes the load off. So you can uncheck all these if you want. Another one is if we go over here to offload RCU callbacks. For the people who don't know, your ZFS threads are processed on the same RCU callback thread. So if you separate those RCU callbacks and you pin them to specific CPUs, that's where your ZFS is going to be hitting. In fact, I'd recommend kind of like an even 50-50, like half, like if just as a default, like use like put like half of the RCUs on half of your cores and the other ones don't touch, and then like give them a priority boost. That would be good. So I'm just gonna keep it like that. Scheduler features, I don't need to worry about that. NUMA placement aware scheduler, yeah, there's no reason why you wouldn't want to have that. Control group support, this is another important one. This can axe your performance and it can totally save you. In fact, you can set up a really nice KVM virtual machine without having any type of without separating your KVM threads from your main threads or CPU isolation at all, if you could figure this right. So for that, what I would do is I would do this one, like the device controller, and I can't remember if you need memory or not. I don't think so. So I think this is all you need for Docker, but I can't remember in all honesty. So this one, the group scheduling for FIFO, this one's good. You can keep it on or off, but if you're running lots of FIFO task party and real-time tasks, this is good because it will balance it out, keep it from fighting, and it won't really take a hit on your real-time. So that's a good one to keep on too. Another one is your, this is pretty much how I said it. Once you get the RDMA, the freezer, and you start checking all this stuff, it completely destroys your performance because there's way too much management going on. So this is a good setup right here. Another one, if you do, let me see, if you go down here, I'm trying to remember what some of this stuff is. Okay. Oh, automatic process group scheduling. This is good too. I would keep it on. That mixed with the current setup is good. It's good. So I'd keep that. Now, if you start putting all that stuff, then the automatic process group scheduling is going to do the exact opposite. It's going to murder your performance. But with that setup, it's real nice. Right here, I'm going to keep resource control support. Why not? I'll keep this. Linux guest support. You can do this. This is all for like your guest stuff. Keep in mind, this might just do a little bit of a trusted domain execution. No, not that. All right. So you can keep all this stuff on, but I kind of wouldn't. I don't know. You can keep it on, turn it off, but it will give you a tiny little hidden performance metric. But in all honesty, it's not really going to hurt anything either. Another thing is process vendors. You're going to make sure you just got the processors you're going to use. DMI scanning. This is important if you want to know everything there is to know about your hardware. Multi-core performance monitoring. Yeah. Machine check injection. Yes. This is pointless. 5-level page tables support. It's for like massive amounts of RAM. You know, why not? It's good to have some of this stuff on. But you don't want to like go into overkill it either. These are your mitigations. I always keep them all off. I don't like security mitigations. You look at some benchmarks, they absolutely hammer you sometimes. Energy model, we're going to go ahead and do this. Once you set those kernel parameters, it's going to override this. So it's good just to have in there just to, you know. But at the same time, if you want your kernel to be as fast as possible, then no. You want to gut it and take it all out. Another thing is your ACPI support. This is what I run. You can also run something similar to like this. Just check it all if you want to. You can keep all your ACPI stuff on too, or you can turn it off. And here's this. You can set your performance governor. I always set mine to a default performance. Here's your Intel clocking control driver interface. I usually keep that one on. Fault support governor. Yeah, why not? Your I/O schedulers. If you want maximum latency, you can't beat BFQ, but it will absolutely hammer your performance. In fact, I recommend keeping all these off. Just stay away from any I/O controlling at all. Just let it go freely. I play with it a lot. Yeah, and have maxed my systems and stuff. I've just seen only bad from it, so I just stay away from it. Like really, really nasty performance hits and like way too much management going on. There's transparent huge pages. Continuous memory allocator, you may or may not want this. So what you can go ahead and do with this is if you check this right here, and like let's say you check this right, here's your hardware poison injector. You can keep that on or off if you want. There's your idle page tracking. If you go down to here, where is it? Library routines, yes. So whenever you check that, you're gonna see your DMA memory allocate. You're gonna see this pop up, and you can go tell how much megabytes do you want your RAM to be set aside for like stuff like direct memory access and other stuff. So it's good, you know, just do like a small amount, maybe like I don't know, like 4096, like just 4 gigs. You know, that's good, right? That would be a good one. And then for your console fonts, I always check all the ones that don't say all your drivers. If you look right here, here's your Rust hacking. So if you compile the kernel in a specific way or enable certain flags, you'll see that enabled. Go ahead and turn stuff on. Fault injection framework. Rust hacking, that. Stack backtrace support. That kind of takes huge shit. Oh, how did this get turned on and on? Oh, tracer. Yeah, I always like latency because this comes in handy with stuff, so I like to keep that on. Here's your cryptographic stuff. Here's that. Here's your device drivers. So here's your SCSI stuff. Yeah, it's good to keep on. You know, SCSI media, blah blah blah. SCSI transports, you know, if you're going through here, it's also good, you know, maybe just only enable your card and not a whole bunch of other stuff. So you can do that right here. Vert IO right there. There's that. You got some other stuff in here. Here's your device handlers and stuff. Another one that's good to do is default SATA link power management policy for low power chipsets. Just do one that's like the best performance. You go ahead and go over to here. Let's see here. Input device driver support. Oh, another one that's extremely important that you need to know about is that if you're going to be doing like oh, I don't know. I'm trying to think how to say this. Oh, VMware balloon driver, this kind of stuff. One that's really important is your graphics. Graphics support right here. Okay, something you need to know about right here that's really, really important. So, I'm just using one graphics driver, so I'm going to turn this Matrox one off. I do that because I have a server. With that card in it, and it will take over like one of the displays, and I'll have to like redo the display. So I just turn this off. That way, right when it hits the OS, it switches over to the other monitors. It doesn't even have a drive for this. That one. There's your NVIDIA cards. Now, when you're building this in the kernel, you need to make sure you pass through those PCI IDs, because if you're building this in VFIO PCI ID, is not going to be able to take it. Another one, frame buffer devices right here. This is important too. So if you do support for frame buffer, whenever you do frame buffer, I'm just going to let you know, if you do the wrong frame buffer setup, you will freeze every time on post. So this is what I recommend. EF5, VESA, user space, VGI. Don't even bother getting the frame buffer drivers for your NVIDIA card or any of them. Just use those. Trust me. That's it. If you like do simple frame buffer here, it'll break it. If you do the frame buffer up here, it'll break it. If you do the VGA and other frame buffer, it'll break it. Okay. So that's about what you need to know right there. From what I can remember, yeah. And then go to sound cards. You know, you can enable all your sound devices right here and stuff, which is pretty good in general. So you can, you know, just make sure it's all enabled. Another nice thing is you can do here too, it's in the multimedia stuff. You can build in a lot of codexes directly into the kernel, which will help with some latency-based stuff. Here's your error correction. If you're using ZFS and stuff, you're going to want to make, with ECC, you're going to want to make sure all your error correction stuff is on. Another thing too here is, what is it? Yeah, we'll keep that on. Here. These are like your universal flash storage, like your little add-on cards and stuff like that. Your USB. That's when you gotta be careful with. Turn too much stuff on, it's not gonna work how you want it to work. Multimedia. Here we go. So if you go right here, this is where you can go ahead and turn on like your V4 Linux, and you can turn on all this nice stuff. And like here's your USB drivers, and then here's your PCI drivers, and for like different capture cards and stuff like that. So this is something I would definitely recommend like checking, especially the especially like what was I gonna say? It's definitely something I recommend like checking, like especially the codecs and stuff. Decoder driver, yeah, right now. So anything that has to do with like codecs and stuff, I definitely turn on. Now I went overkill on this. Like this is a full-fledged kernel for like multiple systems and stuff, and for the most regards, like I won't even be using all this. Which in reality, you shouldn't really want to build a whole bunch like this, but because I want to have everything be compatible, and I'm going to use this for other systems, this is how I'm going to build it. And I just, I don't know. I play with gutted kernels and stuff, and I've only noticed a difference whenever you turn on like IO, IO's low latency scheduling and like the CPU resource management. That's the stuff that you really see performance crunches on. So that's why I stay away from it. Otherwise, you can like build in all the drivers and everything. You don't really see any performance impact. The debugging stuff, yeah, some of it will do a performance impact. So if you see debugging and stuff, you might want to stay away from some of it. Like this one here, video decoders. See, you got video decoders here, and then you go back. You got what else? SDR chips. Go right here, SPI chips. Got this tools, RDS. Then you got your sound card. Anyway, your DMA buff options. There you want your system heap right there. You're probably gonna want that one. Sync file system, yeah, no, DMA engine support, yeah. So this is all your DMA stuff, your direct memory access. It's gonna be pretty important. Well, it's pretty important in certain workloads. In other workloads, it's not. Sometimes they even cause problems. It can be buggy. Let me see here. Oh, so here's more stuff for XN drivers. So you're probably gonna want to have a lot of this on. Yeah, you're probably gonna want to have a lot of that on. Microsoft, yeah, you're probably gonna want this on too. So this right here, yes, DDR, yeah, that's performance monitoring stuff. Power cap driver, uh, you know, PHY. A lot of this, your PHY stuff is a lot mostly for networking. Your reset controller device. So like, if you're doing a performance system, you can like take off all the reset controller stuff. You can do a whole bunch of other stuff. I'll get into that later. I think I'm gonna go ahead and later on I'm gonna add to the kernel so it will automatically tune your build for like it will cut off everything you don't need. And maybe we can make it so yeah, you just pay ZFS. And you know what? We're just gonna go ahead and turn. I'm just gonna turn all this on because I'm just gonna have this be one fat kernel. So that's about all I can think of right now. Um, so this one, this one, this one, this one, this one. So if we do IO schedules, yeah, definitely stay away from those. That'll get you. It'll get you. Okay. Enable support for block right back throttling. Yeah. With this memory, blah 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 blah. Hardware poison pages, free page. Yeah. So another one I would never turn on. I just completely forget about swap. That's one thing too that I've noticed. Swap sucks. Just stay away from it. You'll be happy. Trust me. Okay, so that's about everything I can think of right there. I'm just gonna go ahead and save this kernel. It's saved, and we're just gonna go ahead and let it build now. So the next time it should interrupt you is about the built-in ZFS